Hi everyone. So this is a demo that I'm doing of a project I did a few summers ago called Towers of Hanoi. So this is a very classic math puzzle, and I have the version set up here that is basically 3 towers and 3 disks, and you follow a set of rules to move the 3 sets of disks to the from the source tower to the destination tower. And basically the simplest rules for the standard variant is that larger disks cannot be placed on top of smaller disks, and only one disk can be moved at the time. So let's go ahead and play this simple version. So you drag and click. And there we go. So I'm going to reset this. And this is a pretty cool project that I did because I kind of wanted to see how, the Towers of Hanoi works and whether there's an optimal strategy, what is the best solution, fastest way to get from the source tower to the destination tower, so on and so forth. And I kind of went overboard on the different types of controls you can have to modify the puzzle. And so we have the standard variant, as we just seen, and we also have like bicolor and adjacent, which have different set of rules. We can also add number of towers and number of disks to control the complexity of the puzzle. We can switch the source towers. This doesn't really do much. Same thing with the destination towers. We can change the background into a different vibe. If you like serene lake, I guess this is a good choice. Yeah, we can also change the texture. So if you'd like a woody texture, you could change that. Let me change it back to standard 3 disks. The coolest feature I would say that I've made is to animate the puzzle from start to completion. So for example, if you're stuck on a puzzle, I can always find a way to animate a solution out of the current state. So let's say the puzzle is in this current state and you're stuck, right? You can go ahead and animate. We give like 15 steps. We give a hint towards like how many steps you need to take to finish the puzzle optimally. And you can also have a set of play rate for if you just want to animate the solution. So just go ahead and do that. So this is 50%. It's kind of slow. And we are basically following the same exact rules while animating the solution. Yep, there we go. If you want to keep track of how many steps you took, you can log in using Google. And here, this is a convenience navigator for different types of levels. So you can select the number of towers and number of disks using a grid or table. And this updates based on if you're signed in or not. And that is pretty much it. So we can take a look at some of the source code for this project. And I would say like the most interesting part of this project was getting the animation to work. And so kind of like what that entails was getting animation steps from a certain state. And so you can imagine we pass in game state, we pass in the initial disks, and we pass in the source and destination towers. And this is basically what we need in order to figure out what the next step is, right? We also pass in procedure, which is like what kind of variant we have here. And so I'd say the hardest variant to code the solution for would be the bicolor variant. And so the bicolor variant is basically another puzzle variant of the Towers of Hanoi classic puzzle. And we are basically adding a few set of rules on top of the classic puzzle. So this is kind of what it looks like. You have basically 2 duplicate towers of disks, and you have corresponding disks. So you're doubling the number of disks, and they have the same size, but they have 2 different colors. And so the basic idea is you're still moving smaller disk on top of bigger disk, and you can't move a bigger disk on top of a smaller disk. But the idea is at the end of the solution, or at the end of the puzzle, you should have all of the same color disk on the source tower and all of the other color on the destination tower. We can definitely play the solution to see how this would look like. And so the idea for the solution is to move all the disks in order to the central open tower, and then slowly start to build the two of the same color towers on the source and the destination towers. And so that's how we establish the base for these two towers. And we move all the other disks, the smaller disks, to the open tower again, and we just redo it. And finally, we have the solution. And that's basically what the code does here. It's a recursive approach that basically moves all the towers to the open tower in order to move the largest disk to the correct position, and then it repeats that process on the smaller set of disks. And so yeah, that's basically it. Yeah, thank you for watching my demo.